Hello everyone, this is Balu. Welcome to my channel Seal Cave. In this video, I am going to discuss about stiffener. In the previous videos, I already discussed about introduction and also behavior, shear strength and also the shear buckling design methods of plate girder. If you have not yet watched those videos also, please go through that videos because each and every video is interlinked. If you understand the previous videos only so that you can get the knowledge regarding the behavior of the plate girder in the further videos. So please watch those videos, and also I am giving my full efforts to do videos on this plate girder design. And also if you have not yet subscribed my channel, please subscribe my channel and also share with your friends who are working in the civil engineering field, who are pursuing the degree in the civil engineering. So let's get into the video. The first thing is why we have to provide a stiffener in the plate girder. This is one of the important question, so that you have to get the concept from the stiffener. Here, if you observe this plate girder, because of this external load acting on this plate girder, there is a high shear concentration at the supports. So there is a reaction is going to be developed at the supports and thereby develops high shear concentration at the supports. Because of this high shear concentration, it may require very thick webs at this location. And if you are going to provide thick webs at this location and thinner webs where the shear is very less, then in this case, to join that thick web and also the thinner web, the fabrication cost is going to increase. So for that case, they are going to provide thinner webs across throughout the length of the plate girder. But to increase the strength of the plate girder at this particular location where the higher shear concentration is developed, they are going to provide the stiffeners at that particular locations. Generally, the ultimate aim of the engineer is to provide the optimized cross section throughout the length of the plate girder and also to optimize the steel quantity throughout the length of the plate girder. So for that case, you are going to provide the thinner web across the throughout the length of the plate girder, and stiffeners are going to be provided at suitable spacing so that the strength of the plate girder is going to be improved, particularly at the highest shear concentration or higher bending moment locations. This is the important concept regarding the stiffener. And also in the previous videos I already discussed, that is by providing stiffeners at suitable spacing, this panel is going to act as a single unit, and also the tension field action is going to be generated in that panel so that the strength of the plate girder is going to be improved by providing the stiffeners throughout the length of the plate girder. And this is one of the important reason I have already discussed why we are going to provide stiffeners across the throughout the length of the plate girder. And also there are other reasons why we are going to provide the stiffeners. Coming to the other reasons, that is controlling the local buckling. And coming to the last reason, that is connecting bracing. So let's get into these two important reasons for providing these stiffeners. That is, this local buckling occurs when the cross section is slender enough for buckling to occur within the cross section. So whenever the cross section is slender enough, this local buckling is going to occur. And it occurs due to the compression or maybe due to the shear. And this local buckling can occur due to transverse compression load, that is web subjected to bearing reaction. And coming to the second thing, that is longitudinal compression load, and that is due to bending. And also coming to the last thing, that is due to shear. Because of the transverse compression load or longitudinal compression load or due to shear, this local buckling can occur in the plate girder. Now if you observe this first thing, here the transverse compression load is going to act at the supports. Because of this transverse compression load is going to act at the plate girder, there is a development of compression stresses in that unstiffened web plate girder at this bearing position. So to tackle such compressive stresses, we are going to stiffen this web by providing the stiffener at this particular location. This is one of the important reasons why we are providing the stiffener at this particular bearing locations, or you can say higher shear concentration regions. Here you can see this is the buckling profile of the plate girder. And next, coming to the other thing, here based on the change of, it may be shear force or also bending moment diagrams, we can provide the taper sections across the length of the plate girder. So because of this, providing this tapered sections, here you can see this is a profile where the change in flange at the support you can see here. This is the tapered section you can see up clearly. At sudden change in the cross section region, that is, here you can observe this is the sudden change in the cross section region, that is, tapered flange is going to intersect at the normal flange location. At this location also, the compressive stresses are going to develop within the web of the plate girder, and this will also cause the web to buckle. So to tackle such compressive stresses, we are going to provide stiffener at these particular locations. Next, coming to the other case, that is longitudinal compressive load. That means if you observe a simply supported beam and there is an external load which is acting on this simply supported beam, and because of this external load, the beam is going to deflect in this manner. And you all know the important thing, that is, because of this deflection, the top fibers are going to be exposed to compressive stresses, and also these bottom fibers are going to be exposed to tensile stresses. So this is nothing but the bending in the simply supported beam. So for such compressive stresses, the web is going to buckle. So you can say out of plane deformations are going to be caused in this web. To tackle such out of plane deformations or these compressive stresses, we are going to provide longitudinal stiffeners. Anyway, transverse web stiffeners are also effective, but to tackle these longitudinal compressive stresses, longitudinal stiffeners are going to play the major role. In this way, you are going to provide longitudinal stiffeners, but anyway, transverse stiffeners are also effective to tackle such compressive stress across the length of the plate girder. Next, coming to the last case, that is shear. Because of the development of the shear in the plate girder, the panel itself will be exposed to diagonal compression, so that the web is going to buckle due to this diagonal compression. So in that case also, we have to provide the transverse stiffeners at suitable intervals, so that you can tackle such diagonal compression by generating the tension field action in the plate girder. These are the major reasons why we are going to provide the stiffener in the plate girder. In case of ladder deck or multiple girder bridge, it is very important to connect these multiple girders. So to connect these girders, the stiffeners plays the important role. So if you observe this, these bracings are connected to the stiffeners. So if you connect these bracings to the stiffeners, the load transfer mechanism is also going to be very smooth. But if you connect these bracings directly to the web, the load is directly going to act on this web, and also the contact area between the web and also the bracing is very low, so that the load transfer mechanism is also not very effective. So these stiffeners are playing very important role in connecting the multiple girders, so that these girders will act as a single unit and it will be very effective. So in this way, you can connect the multiple girders using the bracings. This is one of the way, and also coming to the other way, here you can see the stiffeners are going to connect the two girders by using the bracing system. And also if you observe this real image here, these two girders are connected by the bracing system by these stiffeners. So these stiffeners are playing very key role in connecting the multiple girders. So in this way, stiffeners are going to play the very important role in the plate girders, and based on the functions, the stiffeners are further divided into different types, and those types I am going to discuss in the further videos. And this is the main important video which is discussed on the why we are going to provide the stiffener in the plate girder. So thank you for watching this video. If you like my content, please subscribe my channel and also share with your friends. Thank you.